Hi, this is a video going over the H1 accelerator. What you're looking at right now is the touchscreen that controls this unit. And what we have is a generator, control board, and supporting electronics that actually generate the hydrogen, keep it under pressure, and meter it through a injector system. And that's based on engine load. And what we'll be doing is going through how we can control that amount of hydrogen and the injector pulse rate. So what we'll do is first turn on the unit, and you could hear the injector working. And to show you it working, we've got bubbling hydrogen right now at idle. So this would be the amount of hydrogen that's being put into the system at idle. Now we could throttle that back or increase it to however we would like, and depending on engine load. So at idle we could put in a certain amount, and as the engine requires more energy, then we could go ahead and add more hydrogen. Let me focus in here. So what we'll do is we'll show. We go to the next, well, here you can see we're at 11 pounds vacuum. The generator's operating at 40 psi right now, and pulse width is about 10.6. We'll be adding a temperature gauge here instead of the RPM, which will tell you the operating temperature of the generator itself. So if we go to the next screen, we're able to see the slope. Now it's set at R1 because we are not using, well, actually it's not creating that much hydrogen, and based on the engine load. So the engine load is virtually nothing because it's at idle, so it doesn't require very much hydrogen. And each one of these scales we could set how much hydrogen we want at the engine load. So if we go to the next screen, now this is the while you're running screen. Any of these could be increased or decreased according to how much load or that shows up here. So if we go here, we could load all the settings, and if you notice we have a bunch of numbers. So it's showing at a negative 14 pounds vacuum. We have it at 0.12 pulse width, and then as it decreases, which means increases in engine load, all the way down to 0, which would be wide open throttle, we have 75% capacity. So what you could do is you could press this parameter. You notice maximum vacuum, which means idle, and the minimum amount of hydrogen going in. And we could go to our next level, and if you notice, as it's requiring more load, we increase our hydrogen. Now these sliders could be set to anything you want. You just press on them and slide it up, or slide them down. When you're happy with it, you press save, and that will become a permanent setting every time the system's cut on. And you could go through each one of those ranges, you notice, and set that up. Okay, so it's already set up, so we won't save it. We'll just go back to our screen. And basically these are all your alarms: high temperature, water's low in the reservoir that fills the system, too high pressure. So we basically max pressure out around 55 psi. So the system will never go over the 55 psi. It'll cut off. And if it does overmax, what it'll do is it'll tell you there's too high a pressure, and then it will shut off automatically and send you an alarm. If the pressure's too low, it'll let you know that. And then we also have a low RPM range. So that's basically the general outline of how the system works. It's all based on engine load and how much hydrogen you want to put into your system at any one of those points. Now these scales, if you look, they actually, you set those loads, but the programming will scale it automatically up and down. So it's not necessarily a step type of gradient. It's a it'll follow that scale. So whatever it's set at, it'll scale from R2 to R3 smoothly. It'll ramp up, and the same with R3 to R4 and R4 to R5. So it's a smooth scaling between those steps. Again, the processors take care of that in the control board. So that's basically how we control the system and what you can look for. This also, we're working on the apps that you could do this through your phone remotely, or a tablet or a laptop. You could control the system many ways.